Hello friends, welcome to my channel Om Ki Pathshala. Today I am going to differentiate between various mathematical concepts. This PPT is all about concept differentiation in maths, which means to differentiate various mathematical concepts. Why am I telling you all about concept differentiation in maths? Because sometimes some mathematical concepts tend to become very confusing, and if you don't understand it properly, then you assume it to be something, but actually they are, and you would think that they both are same, but the concepts are fully different even though they look same to you. So today I'm going to differentiate between some of them. Fractions and rational numbers. Till class 6 we learnt about fractions, and in class 7 we were introduced about rational numbers. Since then many of us are pretty confused in fractions and rational numbers. We think that they both are same because they have numerator and denominator, but they are different. Fractions. A fraction represents a part of a whole or a group of objects. Yes, this was the definition that we were taught. A fraction represents a part of a whole, even it consists of the numerator and denominator. Yes, we know that. And the numerator and denominator are natural numbers. Yes, whatever fractions 1 by 2, 2 by 7, 7 by 3, in these fractions, the numerator and denominator are natural numbers. Some things to note down. A whole number can be expressed as a fraction with denominator 1. Yes, sometimes you are given whole numbers and you are asked to express it as a fraction. So for that, what you can do, you can make it denominator as 1. This is how we express a whole number as a fraction. If the numerator of a fraction is 0, then that means its value is only 0, because as you know, if you dividing a 0 by any number always gives you 0. A fraction cannot have denominator 0, as division by 0 is undefined. Yes, you can have 0 by 3, 0 by 7, that would be 0 only, but you can't have 3 by 0 and 7 by 0, because you cannot divide any number by 0. And another thing, fraction actually represents division. Whatever you have seen are actually division. 1 by 2, 1 divided by 2, 22 by 7, 22 divided by 7. Now let's go to rational numbers. It is of the form P by Q, where P and Q are integers. This is the definition that we are taught, that a rational number is a number of the form P by Q. Again, it also consists of the numerator and denominator, but the numerator and denominator are integers. In fractions they were natural numbers, but in rational numbers they are integers. And again, some things to note down in rational numbers. An integer can be expressed as a rational number with denominator 1. Yes, sometimes you could be asked to express an integer as a rational number. Just like how you can express a whole number as a fraction with denominator 1, you can even express an integer as a rational number with denominator 1. If the numerator of a fraction is 0, then its value is 0. Again, as fractions, 0 by 7, 0, 0, 0 by minus 2 will give you 0 only. And a rational number cannot have denominator 0, as division by 0 is undefined. Yes, you can't have 8 by 0, minus 10 by 0. That would not, there is no rational number that has denominator 0, because division by 0 is only undefined. And another thing, mostly we keep the denominator of a rational number positive, so that it is easy for us to find the LCM of denominators during addition and subtraction of rational numbers. Yes, sometimes you could have rational numbers like 2 by minus 7, minus 8 by minus 10, like that, minus 8 by 2, 22 by 44. And if the denominator was negative, then it would be hard for us only to find the LCM, and mostly we find the HCF and LCM of positive integers, not negative integers. So that is why we always keep the denominator of a rational number positive, so that we can easily find the LCM of its denominators. Absolute value and additive inverse of an integer. These two concepts we had learnt in the video of integers, but many of you still get confused between absolute value and additive inverse. But they are, you think they are same, but they both are fully completely different. Absolute value, it represents the integer's distance from 0 irrespective of its sign. Yes, I had told you this also. If it just represents the distance of that integer from 0 regardless of its sign, or which direction is it, left or right, whatever, but it represents the distance. It is represented as absolute value of a. These two parallel bars represent absolute value of a, which is equal to a if a is more than 0 and minus a if a is not, if is less than 0. This also I told. Again, some things to note down. The absolute value of any integer, positive or negative, is always positive. Yes, because we are talking about its distance from 0, and the distance can never ever be represented by a negative integer. It is always represented by a positive integer. So the absolute value or modulus would always be positive. The absolute value of 0 is 0. I told this in the previous video also, that absolute value of 0 is 0. And another thing, 0 is neither positive nor negative only, then its absolute value would be 0 only. Additive inverse. It is an integer with the same absolute value as another integer but with the opposite sign. Yes, remember, you get confused by this only. Absolute value represents distance. Additive inverse is same integer with same numerical value but of the opposite sign. If you take 8, it is positive integer, and if you take minus 8, it is its absolute value is also 8, but the only difference is 8 is a positive integer and minus 8 is a negative integer. Same with minus 11, it is negative 11, same absolute value is minus 11 but is of the opposite sign. Minus 11 is negative and 11 is positive. The additive inverse of a is minus a and that of minus a is a. Just now I explained using some examples, and this is what I am explained in, I've written in statement form. This a are variables. Again, some things to note down in additive inverse. The sum of an integer and its additive inverse is always 0. Previous video also I told this. If you take 8, its additive inverse minus 8, add them, 8 plus minus 8, which will give you 8 minus 8, 0. Minus 12 plus 12, minus 12 plus 12, minus plus minus. 12 minus 12 will give you 0. You will always get 0 if you add an integer by its additive inverse. One more new thing I have explained this time. The quotient of an integer and its additive inverse is always minus 1. Yes. If 7, its additive inverse is minus 7. 7 divided by minus 7 will give you minus 1. Minus 20 divided by 20 will give you minus 1. Yes. You will always get minus 1 if you divide an integer by its additive inverse. Algebraic expressions and algebraic equations. Now you reach to algebra. You know that algebra is a very interesting branch of maths. Why? Because learning algebra is more like learning English alphabets, as there are so many alphabets like A, B, C, D, P, Q, R, S, like that. And these are two concepts that you often get confused with: algebraic expressions and algebraic equations. You think they all are same, but they are fully different. Algebraic expressions. An algebraic expression is a combination of variables or literals and constants joined with the signs of operations. Yes, it is just an expression, so if you combine all variables and constants and join them with signs of any operation, plus, minus, multiply, or into, or divide, that would be your algebraic expression. 4x, it is an algebraic expression. 7x minus 4y plus 8xy, again it is an expression. Some things to note down. A variable is a symbol representing unknown quantity. Yes, a variable is also known as literal and it represents unknown quantity. Or you can say a variable is a symbol with that does not have a fixed numerical value. The value of a variable depends on the expression only, right? And a constant is a symbol representing known quantity. You can even say it as a constant is a symbol which has a fixed numerical value, because variable is like x, y, p, q, a, b, c, and a constant is 0, 4, 8, minus 7, like that. For constants the numerical value is fixed, and in variables that is not fixed. An algebraic expression has terms separated by signs of addition and subtraction. The terms of an algebraic expression are basically its parts. Okay, but they are separated by signs of addition and subtraction only. If you take 7xy, 4 by x, that would be one term only, because multiplication and division cannot separate term. 4 and x are not separate, they are one term only. But if you take 4x plus 7y, 4x and 7y are different. 8x minus 2y, again 8x and 2y are different. That means only addition and subtraction can separate the terms of an algebraic expression. Now algebraic equations. An algebraic equation is a statement of equality equating two quantities. Yes, it basically equates two quantity. You can even say that an equation is a condition on a variable. You are putting condition that is this expression is equal to this value. They are made of variables, constants, and expressions separated by LHS left hand side and RHS right hand side. LHS and RHS are basically the left and right hand sides of the equal to sign or not equal to sign. In equations also you have variables, constants, and expressions. One thing is, in equations you have expressions, but in expressions you don't have any equation. This is the main difference between an algebraic expression and an algebraic equation. Some things to note down in algebraic equations. An algebraic equation is said to be linear if its degree is 1. Many of you in class 6 were only taught about simple algebraic equation. For me, this algebra is fully new. And in class 7 we learn about linear equations. What are they? In line only. Linear means in line. That means the degree is only 1. And in class 7 we learn linear equations in one variable. The linear equation can be 1, 2 and 3 variables as mentioned here. In class right now we are learning a linear equation in one variable. When we will go to 8th we will learn linear equation in 2 variables. In 9th we will learn a linear equation in 3 variables. So like every subject, even maths level increases. The value of a variable which satisfies the equation is the solution of root of that equation. Yes, it is whatever value of a variable satisfy that equation, that value is the solution of the equation. You can even say it as root. Squares and cubes and square and cube roots. These concepts you have learnt a lot, but still many of you get confused between squares, square roots, cubes, cube roots. Here is a simple difference. Squares and cubes. If you multiply a number by itself twice, you get the square of the number. Yes, 8 into 8, 8 square, 64. 12 into 12, 12 square, 144. If you multiply a number by itself thrice, we get the cube of the number. Yes, 3 into 3 into 3, 3 cube, 27. 4 into 4 into 4, 4 cube, 64. Some things to note down. For integers, the square is always positive. Yes, For the integer can be positive or negative, but its square is always negative. Minus 2 square is 4. 2 square is also 4. For integers, the cube can be positive or negative depending on the integer. Yes, cube can be positive or negative depending on the integer. 3 cube is 27. Minus 3 cube is minus 27. And when you will go in higher grades, you will learn that brackets are very important for integers. If minus 4 was in brackets, then it would be minus 16. But if it simply was minus 4 square, then it would be minus 16. This concept is very interesting that you learn in detail, because you are only considering the numerical part, not the whole integral part. If you consider the integral part, then you will get minus 4 square 16. But if you only consider the numerical part, then you will get minus 4 square minus 16. Square and cube roots. The square root of a number is a number which, when multiplied by itself twice, gives the original number. Yes, 2 square is 4. So square root of 4 is 2. You multiplied 2 by itself twice to get 4, na? That is why. Cube root is same but a bit different. Cube root of a number is a number which, when multiplied by itself thrice, gives the original number. 5 cube is 125. Cube root of 125 is 5. You multiplied 5 by itself thrice to get 125, na? So 5 is the cube root of 125. Again, some things to note down. There is no square root for negative integers, because the square of any integer, positive and negative, is always positive only. So you can't have the square root of 16. There is nothing. The square root of 16 is either 4 or minus 4. There is cube root for both positive and negative integers, because cube can be positive or negative. 2 cube is 8, so cube root of 8 is 2. Minus 3 cube is minus 27, so cube root of minus 27 is minus 3. Properties of positive and negative integers with respect to exponential notation. Many times you get expressions involving exponential notation of positive and negative integers, and you might get confused or you might get wrong answers. But there are various properties of positive and negative integers with respect to exponential notation. Let's see. Positive integer, if you raise a positive integer to any power, you always get a positive integer. That's true. 3 square is 9. 5 cube is 125. 2 to the power 4 is 16, like that. But for negative integers, there are a magic happens. If you raise a negative integer to an even power, you always get a positive integer. Yes. If the power is even, then the negative integer would result in positive integer. See the examples. Minus 2 square will give you 4. Minus 3 to the power 4 will give you 81. If you raise a negative integer to an odd power, you always get a negative integer. Yes. If the power is odd, then the negative integer would result in a negative integer. See the examples. Minus 3 cube, minus 27. Minus 2 to the power 5 will give you minus 32. Negative integers have these two special properties. Positive integers only have one property, and that is you'll always get a positive integer if on raising it to any power. So that is it ends with our concept differentiation. Now you understood some of the basic concepts which differ by each other a lot. If you want to see such more videos, like, share and subscribe to my channel Om Ki Pathshala, and if you want, I can create more such videos so that you get better in maths and other subjects. See you next time. Bye bye.